You know, some of the most brilliant solutions out there aren't about working harder at all, they're about working smarter. Today, we're diving into a really powerful tool for doing exactly that. A kind of statistical shortcut for solving incredibly complex problems. It's called the Taguchi Method.
Just think about it for a second. Let's say you're trying to bake the perfect cookie. You've got flour, sugar, baking time, temperature, or maybe you're an engineer designing a new product. Testing every single possible combination of all those variables is, well, it's pretty much impossible. So how in the world do you find the best recipe without spending a lifetime in the lab?
And this gets us right to the heart of the problem that scientists and engineers face every single day. When you have multiple factors that could affect your outcome, the number of potential combinations just explodes exponentially. Trying to test all of them isn't just slow and expensive, it's often physically impossible to even try.
So, for a long time, you really only had two choices. On one hand, you have the full factorial approach. This means you test everything. It's super thorough, sure, but it costs an absolute fortune in time and money. And on the other hand, we have the hero of our story today, the Taguchi Method, which uses a really clever, fractional approach to get the most information from the fewest possible tests.
And the difference in scale here it's just staggering. Just look at that second row. If you have 15 different factors you want to test, a full-blown factorial design would require, get this, 32,768 experiments. The Taguchi Method, it gets you the crucial insights you need in just 16. Yeah, 16! That is not a typo. That's the power of working smarter.
So, how does it pull off this magic trick? Well, the secret lies in this really elegant concept developed by a Japanese engineer, Genichi Taguchi, way back in the 1940s. It's a beautiful idea called orthogonal arrays.
Okay, so what is an orthogonal array? Well, you can think of it as a perfectly balanced schedule of experiments. It's kind of like a perfectly balanced tasting menu at a really nice restaurant. You don't need to eat every single dish to judge the chef's skill, right? A few carefully selected representative dishes can give you all the insight you need. That's exactly what an orthogonal array does. It gives you the most information with the least amount of work.
Now, this isn't just some random guesswork. It's a very structured and repeatable process. So let's just walk through how it's actually applied.
First up, you define your goal and you pick your variables. Then, and this is the key part, you choose the right orthogonal array for what you need. After that, you run only that small, smart set of experiments. You analyze the results using some specific tools, and finally, you confirm you've found the best combination. It's a really clear roadmap to efficiency.
Okay, so this method was developed decades ago, but it's actually more relevant now than ever, especially because it's getting the supercharged boost from modern technology. A 2025 case study shows just how ridiculously powerful this combination can be.
All right, so the goal here was to find the perfect recipe for a smart alloy's hardness. The Taguchi Method told them they needed to run 9 specific experiments. But here's where it gets really clever. They decided to physically run only 5 of them, and for the other 4, they brought in an AI, an artificial neural network, to predict the results without ever having to step foot in the lab. So here's what their plan looked like. This table shows the 9 experiments that the orthogonal array told them to run. But take a close look at those bolded lines, S2, S4, S6, and S8, all marked not tested. They just skipped them, on purpose. This is that work smarter idea in action.
And here's what happened next. Boom! The AI model basically learned the patterns from those 5 real experiments and then predicted the outcomes for the 4 missing ones. Suddenly, they had a complete dataset, but they got it with nearly half the time, half the cost, and half the effort.
So what was the actual payoff? I mean, this is where it gets really, really impressive. The savings were totally concrete and measurable.
First, let's talk about the money. By skipping just those 4 experiments, they saved $940. Now, I know, that might not sound like a life-changing amount, but just imagine scaling this up to projects with hundreds or even thousands of tests. The financial impact becomes massive. And honestly, what's even more valuable than money? It's time. They saved over 124 hours of lab work. That's what, more than 3 full 40-hour work weeks. That's time that can now be spent on the next innovation, not on doing repetitive tests.
Okay, this is the big question, right? The one you should be asking. It's awesome to save time and money, but it means absolutely nothing if the predicted data is just garbage. So just how accurate was the AI?
Well, here's the proof. On this chart, remember,
lower is better. A standard forecasting model had an error of about 0.37%. The artificial neural network they used? A tiny 0.11% error. So not only was it accurate, it was more than 3 times as accurate as a traditional statistical model.
Hey, don't just take my word for it. The researchers themselves said it best. They concluded that the neural network predictions were not only a good shortcut, they were actually a better, more accurate predictor of the real-world results. This wasn't just a successful experiment. It was a huge validation of this whole hybrid approach.
All right, let's just zoom back out for a second here. Because this isn't just about making better alloys faster. The principles behind the Taguchi method, they're incredibly versatile. I mean, its reach is just incredible. The same exact logic is being used to optimize manufacturing, develop new chemicals, create financial models, design medical devices, improve crop yields, and even fine-tune marketing campaigns. It's a universal toolkit really for optimization in any field where you've got a bunch of different factors at play.
You know, when you boil it all down, the Taguchi method is more than just a statistical tool. It's a whole mindset. It's about asking, what is the absolute minimum amount of work I can do to get the maximum amount of insight? It forces us to look for the elegant, efficient path instead of just the brute force one. So the question I'll leave you with is this. What's a complex problem in your world that could be solved with a really, really smart shortcut?